Hello, I'm rebuilding my Clemente Figuera Commutator so I could continue with some experiments which I started about a year ago. The commutator version offers many advantages over the electronic version, mostly because you can't blow it up. It's just wire connections. Second of all, you could try much more configurations, which I'm going to be going over. So watch my channel and join the forum to see more. Okay, so the motor spins, the brush is always touching at least one contact, but actually it's touching about two. Okay, so it makes before it breaks, it never loses contact. Okay, I have 16 bars on there, okay, that it's making contact with copper. I made this with a hacksaw and a 3D printer and some JB Weld and whatnot. Anyway, so the brush revolves around the commutator. Okay, the hot wire connects to the shaft of the motor. Then we're putting hot direct current into the shaft of the motor from the bottom with a little brush that connects onto the shaft down there. So it sends positive DC up the shaft out of that red wire, through that red wire that connects to the brush. And the brush connects down to a terminal block and a terminal block. We have 8 terminals here, 8 terminals here, divided in the north and the south, or one side and the other side. Okay, so as a test, I connected all the outputs together on one side, and I'm leaving these ones open. Okay, then I connected a load from the outputs to a resistor back to the supply. Okay, so what we want to see on the oscilloscope is a square wave, a single polarity square wave, up, down to zero, up, down to zero, because when the brush touches this half of the commutator, anywhere it touches should all be flat DC. And when it's on this side, it'll be powering this side DC, but we're not going to be able to see, it'll be zeroed out on this side because it's making connection on the other wires. So to know this commutator isn't jumping, first of all, sparks. Start up your cordless drill and look inside it. You'll see sparks flying. Look at other people's videos. You'll see sparks flying because their commutators suck. Because they're skipping. They're not smoothly making contact the whole time. It's going to spark if you're jumping. And if you're jumping, the whole project's ruined. It has to maintain a connection the entire time. So this part, the design of this is very pivotal. Okay, it can't spark. If there's any sparks, it means it's dropping a connection and you're not maintaining a solid connection. Okay, so here we go. There's the scope. It's powered now just with DC. Okay, now watch. When I come to this side, it's 0. When I come to this side, it's on. When I come to this side, it's 0. When I go past here, it's on. So again, I want to see direct current square waves, one polarity, without it hitting the 0 line, without flyback and all types of weird crap happening. I want smooth square waves to prove that these 8 are working correctly. And after that, we'll test these 8. But you don't have to be watching the test. Anyway, so we start it up. And the commutator is in motion. The resistor is still powered. Now we're going to look at the scope. And there we have it. That's what I pretty much want to see. Nice, pretty clear. Oh, you saw that one little dip down? That's what you don't want to see too much of. If you see a lot of those, you have problems. See, there's one here and there, which is going to be expected as a piece of dust that's under the commutator or something like that, But look how nice those waves are. Now let's look for sparks. I see no sign of any arcing or sparking. Excellent. And the waves. Now I expect it to have a couple little jitters now as the brush works in and gets used to its new, because the brush is going to form and work in on the new commutator in the new arrangement, and the brush is going to be settled in there soon. So I expect to see a couple little jitters here and there, but it's actually looking much better than I anticipated it was going to. Hey, there's a little jitter there, there's a little jitter, but those are the kind of ways we're going to need to see. So next we need to hook up, check the other side, get it all ready, and then we're going to install the resistor rig, then we can get ready to test. So join the forum in the description, and there's another fellow there building a Clemente Figuera device. It's one of the more popular ones that we all work on over there. So if you're interested in such subjects, join over and share what you got, or, you know, come check it out. All right, thanks.